The main application of double integral is to find the area. We are having so many methods to find the area, but one of the simplest method is using double integration. Here the simple formula for Cartesian coordinates. Area formula is nothing but double integral dx dy. In polar coordinates, area is nothing but double integral r into dr d theta. So we know you do the problem by using this simple formula. Find the area of circle. So everyone know the area of the circle is nothing but pi r square. Here we are going to prove this by in the using double integral. So area is, what is the formula? Double integral dx dy. Here also we have to find out the limit. For that we need the diagram. Okay, draw the diagram for the circle. Here what they have given, center is origin, radius is A. Here this circle, our circle has 4 parts. Now we consider only the first part, that is which lies in the first quadrant. Okay, so which is easy to us. So that's why we multiply by 4, because we consider only the first quadrant. Okay. Why we consider only the first quadrant means in the first quadrant only there is no negative. So the lower limit is 0, which is easy to integrate. Okay, now we have to find the limit. First, we find the y limit. For finding y limit, draw a line parallel to y-axis. Here, what is the value of y means? Here, the value of y is 0. So, the lower limit of y is 0. 0 to, here, what is the value of y? Here, it touches the circle. What is the equation of circle? X square plus y square equal to a square. So here y square equal to a square minus x square, and y equal to plus or minus root of a square minus x square. But we are consider only in the positive quadrant. So here y varies from 0 to root of a square minus x square. And the outer integration limit, that is for x. So outer integration limit always should be a constant. So here we have to write lower and upper value of x. The minimum value of x is 0, and here the radius is a comma 0. So x varies from 0 to a. So area equal to 4 times x varies from 0 to a, and y varies from 0 to root of a square minus x square. Okay. Into, here the very important one is the order. Here it is for the variable y. Okay, so the first integration should be dy, second integration is dx. 4 times, write the outer integration as it is. Integration of dy is y. and the limit is 0 to root of a square minus x square dx. Apply the upper limit 4 times 0 to a root of a square minus x square dx. Now the inner integration is over and also we applied the limit. Now we have to do for the outer integration, that is with respect to the variable x. Here we know the very well known formula. Integration of this function is nothing but, what is the formula? A square by 2 sine inverse of x by a plus x by 2 of a square minus x square. And the limit should be 0 to a. 4 a square by 2. First apply the upper limit. Okay, here substitute x equal to a means we will get sine inverse of 1. Sine inverse of 1 is nothing but pi by 2. Plus, here if you are substituting x equal to a means what will happen? Root of a square minus a square. So, 0 minus, when we apply the lower limit, sine inverse of 0 is 0. Here also when we substitute x equal to 0, the whole term is 0. So we will get the 2 to 4 get cancelled. We will get pi a square. So this is the area of the circle. So we easily got by using the double integration. So next problem, find the area between the parabola y square equal to 4ax and x square equal to 4ay. Here they have given two parabola. Okay, we have to find out the area between them. So again, first we write the formula. So our very well-known formula, area is double integral dx dy or dy dx. That is our choice only. Okay, now we should draw the diagram. Why we need diagram means to find the limit, to find the region and find the limits. First parabola is y square equal to 4ax. So y square equal to 4ax is our parabola like this. And x square equal to 4ay. So this is the parabola y square equal to 4ax. And this is the parabola x square equal to 4ay. So the area between the parabola. So this is our region. So here the point of intersection is origin. And here what is the point of intersection? That is 4a, 4a. When we solve these two equations, we will get 4a, 4a. Okay, we need y limit or x limit we can find in the beginning. That is our choice only. If I am finding x limit first means draw a line parallel to x-axis in the region. Here what is the value of x? Here x touches this parabola. Okay, x equal to y square by 4a. 2. Here, what is the value of x here? Here, x touches this parabola whose equation is x square equal to 4ay. That is nothing but x equal to root of 4ay. That is 2 root ay. This is the inner integration limit. And outer integration limit y is always should be constant. So here the minimum value of y is 0 and maximum value of y is 4a. So 0 to 4a. So area equal to 0 to 4a y square by 4a to root of ay. Here this is for the variable x. So the order should be dx dy. First, we do the integration with respect to x. So, integration of dx is x. x y square by 4a 2 root ay dy. Now apply the limits. Upper limit is 2 root of ay minus y square by 4a dy. Now we have to do the integration with respect to y. Okay, 2 root a is constant. What is the integration of root y? Root y integration is, root y is nothing but y power 1 by 2. Okay, so y power 1 by 2, that is x power n plus 1 by n plus 1. So y power 3 by 2 by 3 by 2. So y power 3 by 2 by 3 by 2 minus, for the second term, write the constant as it is, y square integration y cube by 3. 0 to 4a. Here it is 4 root a by 3. Apply the upper limit. Y. Y is 4a power 3 by 2 minus 1 by 4a. Y is 4a means 4a whole cube by 3. When you apply the lower limit, both are turns to 0. Both the terms are turns to 0. Now we have to simplify. 4 power 3 by 2 is nothing but 8. 8 into 4, 32. When we simplify root a into a power 3 by 2 means a square by 3. Here also 4, 4, 1, 4 get cancelled. We will get 4 square. So 16 a square by 3. So which is nothing but 16 a square by 3. So now we do the problem under using polar coordinates. Find the area between the circles r equal to 2 sin theta and r equal to 4 sin theta. Okay. So here they have given in the form of coordinates the polar theta comma r comma theta. For r comma theta, so first we write the formula area equal to double integral r into dr d theta. Okay, for r equal to 2 sin theta, we have to draw the diagram. So here it is theta equal to 0, theta equal to pi by 2, theta equal to pi, and theta equal to 3 pi by 2. Okay, here how to draw the diagram for this. Okay, for various value of theta, we have to find the corresponding value of r. Okay, first give theta value is 0. When theta equal to 0, what will happen? R equal to 2 sin theta is 0. So when theta is 0, it is 0. Okay, wow. Next, when we give theta is pi by 2, what will happen? Theta is pi by 2 means R value is 2. So it will take value up to 2 here. In between 0 to pi by 2, we are having so many values. Isn't it 0, 20, 30, 45, up to 90 degree. So we are having a circle like this. And similarly for pi, what is the value of r means? Again, it is 0. So for pi, it is going to 0. In between 90 to 180 also, we are having so many values. So it is a circle like this. So that is for r equal to 2 sine theta. And similarly for r equal to 4 sine theta, when theta equal to 0, when we substitute theta equal to 0, r value is 0. Theta is pi by 2 means r value is 4. Theta is pi means r value is 0. So it is also a circle, but here when theta is pi by 2, it is 4. So it is bigger than the previous circle. So it is a circle like this. So this is our region. Okay. Now we have to find out the limit. The limit is very important one. R limit and theta limit. R is nothing but it is a ray from the origin. See here in the region, the R touches here and here. So here the equation of the R is 2 sine theta. That is the small circle. Here it touches this circle whose equation is R equal to 4 sine theta. So R varies from 2 sine theta to 4 sine theta. And what about theta means? Theta, that is, it is lying in the first and second quadrant, our circle. So theta varies from 0 to pi. So area equal to double integral r into dr d theta. R varies from 2 sine theta to 4 sine theta. And theta varies from 0 to pi. Okay, now we do the integration 0 to pi. R integration is r square by 2, 2 sine theta to 4 sine theta d theta. Take off outside 0 to pi. Apply the upper limit means 16 sine square theta minus lower limit r equal to 2 sine theta. Here apply means we will get 4 sine square theta d theta. So we will get 12 by 2, that is 6, 0 to pi sine square theta d theta. We know how to integrate sine square theta by using the formula 6, 0 to pi 1 minus cos 2 theta by 2 d theta. So 6 into, now integrate. Integration of half, that is nothing but theta by 2. The next term is cos 2 theta integration sin 2 theta by 2. But already 2 is there, so it is 4. So apply the upper limit. 6 into pi by 2 minus, here when we substitute theta equal to pi means it is 0. When you apply the lower limit, both the terms are 0. So the answer is 3 pi.